Okay, next let's do the plotting for the book plot. So in this video, I will show you how we can draw the book plot using the semi-log graph. So the semi-log graph means that the y-axis is the linear scale and the x-axis is the log scale. And then for the direction for the log axis, the changes of the width between one point to another point. Okay, if you see this one to this one, the width is y. As the value of the frequency increase, this is the increase direction, so the width become narrower. So this is the correct direction. So if you are given a semi-log graph, so make sure the direction of the semi-log is correct. So for example, this is not correct. Okay, this is not correct because it become the increment direction is towards the left side. Okay, so this is one of the reminder. So you need to be be reminded that make sure the direction of the log scale is correct. Okay. After that, when you have the semi-log, next you can put your axis. So let's say I put the axis here. This is frequency, and then this is the gain. So this is gain, and then the unit of gain is dB, and then this is frequency, the unit is the hertz. Okay, so you see when you do the plot, you see the value of the frequency. So the maximum is 100 hertz, and then the minimum is 2 hertz. So the maximum, let's say this one is 100. So below one cycle is 10, below one cycle is 1, below one cycle is 0.1, and then this is 0.01. So this is how you label the x-axis. And then next, for the gain, so this is the AV mid. So AV mid is the maximum gain. So we put here, this is our maximum. This is our maximum 40. Let's say this is 20. This is 0, minus 20, minus 40, then this is minus 60. Okay. After you finish label the axis, so you can draw the midband line. So the midband line is above the you see the calculated or the given frequencies. So and then you choose the highest one. The highest one will become your lookup of frequency. In this case, the highest is FL1, which is 100 Hz. This is our FL. So above 100 Hz, this the BJT operate at the midband. So the gain is 40 dB. So above 100, the gain is 40 dB. So the line is So the line is that I insert the okay. So this is the line of this is the midband. So the midband is until the FL1. So below the FL1, so one capacitor will appear. So the roll off is for the F less than FL1, it is minus 20 dB per decade. Okay, so minus 20 dB per decade is also in the region where the frequency is above the second highest. So the second highest is 50 Hz. This is FL1 and then FL2. So for the frequency between 50 Hz to 100 Hz, the slope of the gain is minus 20 dB per decade. Okay, this is FL1. FL2 is 50 Hz. So 50 Hz is 1, 2, this is 2, 20, 30, 40. This one is 2, 20, 40, 20, 30, 40, 50. So this is FL2. So this is 500. So this is, sorry, not 500, 50 Hz. This is 50 Hz. Okay, so between 100 Hz to 50 Hz, the slope is 20 dB per decade. Okay, if you want to use the 20 dB per decade, so you need to find, in order for you to draw the one line with the slope of 20 dB per decade, you need to have another point below the initial point, 1 decade below the initial point. So in this case, the initial point is FL1. FL1 is 100 Hz. So below 1 decade of 100 Hz is 10 Hz. So this is below 1 decade. At below the 1 decade, the gain will be reduced as much as 20 dB. So initial gain is 40 dB. After 1 decade, so the gain will be 20 dB. So at 10 Hz, so the gain is 20 dB. Okay, so this is the line. So I draw the line. Okay, this is the line of 20 dB per decade. This is the line of 20 dB per decade. Okay, so but there's one thing that you need to remember. This 20 dB per decade is only until FL2. So FL2 is until at this is 20, 30, 40, 50. So FL2 is this is FL2. So means that above the below than FL2, okay, so the roll off is increased to double, which is minus 40 dB per decade. Okay, so below than this, it is double, so you need to ignore this part. Okay, you need to ignore this part. So what happened is this blue line will be only until this FL2. So yeah, let me redraw it again. So we put it, this is as the dash line. So the correct drawing is until this point. So until this point. Okay. Oh, below than FL2, the roll off is different. The roll off is 40 dB per decade. So in order for for us to draw the line with the slope of 40 dB per decade, you need to know the initial gain. The initial gain at FL2 is around, let's say this one is 34. Okay, let's say 34. So the gain at FL2 is 34. Okay. So FL2 is 50 Hz. So one decade of 50 Hz is 5 Hz. So the 5 Hz is 2, 4, 2, 3, 4, 5. So this is FL3. So the next region is between FL2 and FL3. So in this region, the slope is minus 40 dB. Okay. Oh, sorry, this is not FL3. This is a 50 Hz. This is, sorry, 50 Hz. This is a 5 Hz. Okay. At 5 Hz, if the initial gain is 34 dB and then the roll off is 40 dB, after one decade, from the 50 Hz, which is a 5 Hz, at 5 Hz the gain should decrease minus 40. So 34 minus 40 is minus 8. Okay, minus 8. So at 5 Hz, the value is minus 8. So where is the 5 Hz? So this is around, this is the plot of frequency 5 Hz, and then the gain is minus 8. Okay. And then starting from this one to this one, this is your, okay, this is the your dB minus 40 dB per decade. Okay. So this line is not reaching our last FL3. FL3 is at the 2. Okay. FL3 is at 2. FL3 is at 2. So this is our FL3. So what you need to do is you need to extrapolate this straight line until it reaches the FL2. Okay, so the next region is the line for the next region is from this along until this line. Okay, so this is our FL3. Okay, for the frequency below than FL3, so this is FL2. Okay, the dB is minus 60 dB per decade. So at the FL3, the gain is say this is, let's say, minus 25. Okay, let's say minus 25 dB. Then FL3 is 2 Hz. So one decade below is 0.2 Hz. Is 0.2 Hz. So at 0.2 Hz, the gain will be minus 25 minus 60. So this will be minus 85 dB. But now, but here, our plotting for y-axis, the minimum is minus 60. So using the dB per decade is not that practical. So in this case, instead of using the dB per decade, you use the dB per octave. Okay. So minus 60 dB per octave is equivalent to the minus 18 dB per octave. So what is octave? Octave is the change of twofold. So if the initial frequency is 2 Hz, after 1 octave, the frequency is 1 Hz. So at 1 Hz, the gain should be minus 25 minus 18. So minus 25 minus 18 is minus 43. So should be at the 1, this is minus 43. So from this line, okay. Okay, this is 18 dB per octave or 60 dB per decade. Okay, this is the final drawing for the book plot. Okay, see here, there is 1, 2, 3, 4. We have 4 regions. The first region is the mid-band. This is the first region is the mid-band, where the frequency is fixed at the 40 dB. And then we have the second region is the frequency between FL1 and FL2. So here the roll off is minus 20 dB per decade. This is our second region. And then the third region is between frequency of FL2 and then so the frequency is, FL2, this is FL2, and then this is FL3. So this is the roll off is minus 40 dB per decade. And then the last region is the fourth region is where the frequency is below than FL3. So here the roll off is minus 40 dB per decade. Okay, so here you can use when you plot the book plot, you want to plot the book plot manually. So please be remember that you need to have use dB per octave in certain case. For example, when your scale for y-axis is not that large, so you can use the dB per octave. So the 20 dB per decade is equal to 6 dB per octave.